Hello there. What we're going to look at now is how to solve an exponential equation where the bases don't match, nor can they be written as a form of the same base. So here we're wanting to solve 3 to the 2x minus 1 is equal to 5 to the x plus 7. Notice 3 is not the same as 5, nor can I write them as powers of a same base. Now I do have it where I just have one term on each side of the equation. So what I can do here is take the log of both sides, and because there's not a specific base that would be more beneficial, we can choose between, say, the natural log or the common log, and I'm going to go ahead and take the natural log of both sides. The reason we would pick one of those two is that they have direct calculator buttons, so if we wanted to get an approximation at the end, it would just be a little less with our calculator work to do that. So we're going to start by taking the natural log of both sides, and we can do this because exponential are one-to-one as well as logs are one-to-one. So since the quantities are equal, the logs will be equal. We also needed to make sure that our expressions were not were positive numbers, and I do have that with the exponential expressions on both sides. All right, now that we've taken the log of both sides, we can use the property that the log of a quantity to a power is equal to the power times the log of the quantity. So on the left, we will have our exponent 2x minus 1. Now that has more than one term, so you have to put that in parentheses, times the natural log of 3 is equal to, and on the right, bring down the exponent, we have x plus 7 in parentheses times the natural log of 5. Now here's where sometimes students don't immediately go through and make it easier to solve for x. Remember, we want to solve for x. So in order to do that, we do need to remove the parentheses here. Now the natural log of 3 is a number. It's an entity together, and it's a numerical value. So that's just like a constant. I can distribute that through. Well, and it's not just like a constant, it actually is a constant, so I can multiply that through. Natural log of 5, same thing. It's a constant, so I can multiply that through with the distributive property. So I have 2x times the natural log of 3, and then negative 1 times the natural log of 3 is negative the natural log of 3 is equal to, and then x times the natural log of 5 plus 7 times the natural log of 5. Now we want to go through and get all the terms with the variable on one side of the equation. So I have my term 2x times the natural log of 3 has an x in it, minus the natural log of 3 does not have an x. On the other side of the equal sign, x times the natural log of 5 has the variable x in it. So we want those on the same side. Let's go ahead and subtract x times the natural log of 5 from both sides. So I'll have 2x natural log of 3 minus x natural log of 5, and minus that natural log of 3 is still over there, is equal to 7 times the natural log of 5. Now next we want all the terms without the variable on the opposite side. So this minus the natural log of 3 does not have an x in it, and so it should not be on the same side of the equal sign as the terms that do have the x. So we'll go ahead and add the natural log of 3 to both sides. So 2x natural log of 3 minus x natural log of 5 is equal to 7 times the natural log of 5 plus the natural log of 3. And then on the left-hand side, our common factor of x can be factored out. So when I factor out the x, I have x times 2 times the natural log of 3 minus the natural log of 5. And then bring down the right-hand side. And then lastly, divide both sides by that quantity that is multiplied to your variable. So we are going to divide both sides by 2 times the natural log of 3 minus the natural log of 5. And we will get x is equal to 7 times the natural log of 5 plus the natural log of 3 divided by 2 times the natural log of 3 minus the natural log of 5. And That is an example of solving an exponential equation when the bases don't match, nor can they be written as a power of the same base.